Hi guys, I'm presenting on the structural geology of central Newfoundland. So, quick overview of my presentation. I'm going to start with the location of Newfoundland and the sort of regional geology, and then move on specifically to the dunnage zone and the three subzones within it, and then talk about some of the characteristics of the region, like the dunnage melange, just an overview of the deformational history throughout different periods, and end with the Aegean Ocean suture zone. So, a little overview of the region. If you don't know where Newfoundland is, it's just off the coast of Canada, right under Labrador. There's a larger world map and a little bit of a zoomed in version. It's right on the Atlantic Ocean, not too far from the coast of Canada. And so this is sort of the overview of the bedrock geology of the island. The dunnage zone is the central one over there, and a lot of the rocks from this region are from the Cambrian to Silurian or Cambrian to Ordovician. There's a lot of sedimentary rock, island arc volcanic rocks, ophiolite sequences, ultramafic rocks, pillow lava, all that sort of stuff. And some intrusive rocks that also are in the region that are shown up there. So Newfoundland can be split up into 4 tectonic terrains: the Humber zone in white, the dunnage zone in the middle, which is the one I'm going to be talking about, the Gander zone, which is the smallest, and the Avalon zone over here. So, overview of the dunnage zone. This is basically the same map, but a bit more in depth. It shows the 3 subzones within the dunnage zone. They are the Notre Dame subzone up here in the lighter blue, the Dashwoods in the purple, and the larger exploit subzone here in green. So, some characteristics of the region. I already talked about the dunnage melanges found here, and I'm going to go a bit more in depth with that in a bit. Same with the Aegean Ocean suture zone. That's that line right here. It's also called the Red Indian line locally. And another cool feature about this region is it has a lot of volcanic rock and ocean crust exposed from the suturing of the continents, the suture zone there. And a lot of the sedimentary rocks are of a deep marine origin. So, brief description of the 3 subzones. In the Notre Dame subzone, the one in the north, there's a lot of volcanic rocks and mafic dikes. And I also thought it was cool that it was within that subzone, it was also split into 3 more fault-bounded different parts. And there can also, it's also home to a sub-Silurian unconformity, which I will talk about in the deformational history. In the exploit subzone on the other side of the Red Indian line, it's more of a continuous sedimentary record, but there's some dismembered ophiolite sequences, but more sedimentary rocks than volcanic, and it's bounded by the Red Indian line, which we saw in the other map. In the Dashwood subzone, there's a lot of high-grade metasedimentary schists and gneiss and more ophiolite complexes, and in that metasedimentary unit, one of my readings said there was a lot of sheared rocks in that sort of unit. So here's a bit of a close-up of that Red Indian line, that suture zone. There's different, 2 different ophiolite sequences on that side. It doesn't show any on the exploit zone. I don't know why, but it only shows the Dashwoods subzone, which would be down here, and the Notre Dame subzone, which would be more up here. And 2 different ophiolite like complexes, sequences, and closer right along the ridge, there's a lot of unsubdivided volcanic sedimentary rocks. So moving on to the dunnage melange, one of my research articles described it as a chaotic, heterogeneous assemblage of unsorted blocks set in a fine-grained matrix, which I thought was a pretty accurate description. As you can see in the pictures here from that same reading, there's a lot of foliations, folds, and clastic dikes, which they said was evidence for trapped pore fluids under the surface. And typically, melanges are evidence for accretion or subduction setting, and it was also in a few years back was found to be mid-Ordovician in origin. So though it was set about the same time as the Aegean Ocean when it's sutured together, then it's evidence for an accretion zone. I found it was actually not related to the closure of the Aegitis through a couple different research articles, which I thought was interesting because some of the older readings had kind of lumped the two together, but recently it was found they weren't related. But the origin, the mid-Ordovician origin, wasn't concluded until recently. I think the article was published in 2012. Before that, the soft sediment deformation and the deformation of lithified rocks kind of made the origin hard to pinpoint. But the article I read, they looked at the, I think they're called the xenoliths and the xenocrysts in the, within the melange, and dated those and found it to be mid-Ordovician in origin. So here's just some more pictures of it. Those are the different folds and foliations within the rocks. It's a big old mess. And this is the sort of a overview of the formation of it. So there's the forearc, and that's where the Dunnage melange was formed along the Aegitis ridge. And there's the volcanic setting of it. So moving to the deformational events throughout history, in the early to middle Ordovician, the Aegitis ocean crust started subducting on both margins, so that was sort of the beginning of the suture. And then in the late Ordovician, by the end Ordovician, early Silurian, it was completely closed with the tectonic orogeny, which we see down here. So that's the ocean and the two continents fully sutured together in a subduction zone. And then in the early Silurian, this is the unconformity that we see in the Notre Dame subzone. Older Cambrian and Ordovician rocks were uplifted and eroded, so those were exposed, and that created that sub-Silurian unconformity that we can see today. And in the Devonian, there's the Acadian orogeny. In the Carboniferous, there's the Appalachian orogeny. This is just kind of an overview of the three of them. Those three orogenies together made the Appalachian Mountains, which are also present in Newfoundland, and they're present in the US. We also see the effects of it up there. I'm not going to go into that too depth because that was a different topic, so I didn't want to get into that. So going to the Aegitis Ocean Suture Zone, also called the Red Indian Line. As I said, it was closed by the end Ordovician with the tectonic orogeny. It was the suturing of Gondwana and Laurentia, and it was described as an attempted eastward subduction beneath the island arc, but it resulted into an emplacement onto the continent. And so that emplacement, that suturing, resulted in large-scale folding along that line. There's a lot of overturned folds. They were overturned southwards in the east and northwards in the west. So they're different depending on the region. And that's an example of the Wilson cycle, which is the formation and the closing of oceans throughout time. So same map again, just highlighting. This is the region that we're talking about. That's the Red Indian Line. And this map splits up. This side was the Laurentian margin that was sutured to the Gondwanan margin. So that's where they meet right there. And then that figure is an example of a Wilson cycle where there's rifting and then the ocean basin forms. There's volcanic activity and a subduction zone. And then the ocean basin starts closing. And that stage 5 is what we see now, where there's a suture zone, lots of folding along the mountain range, but it hasn't gotten quite to that stage 6 where it erodes and the crust thins because it's still very thick in that area because there's still the mountain range there. And here's just a comparison of the world map, starting with the Ordovician. The Aegitis Ocean is in this region. You see the two continents are split apart, and then by the Silurian, the ocean is gone. Two continents are sutured together. Okay, so summary of my presentation. The Dunnage Zone is made of 3 subzones: the exploits, the Dashwoods, and the Notre Dame. They all have volcanic and sedimentary rocks mixed in the Dunnage melange, which is not related to the closure of the Aegitis, though they are about the same age and origin, and it's typically evidence for a suture zone. And it's a big old mess, as you can see by the picture, as we know melanges are. And the Aegitis Ocean Suture Zone formed with the tectonic orogeny and resulted in large-scale folding in the area.
of volcanic sedimentary rocks were?
Those?
Yeah.
Those were just like ones that they didn't put in a complex or in a region. It's just like the sort of mess of volcanic and sedimentary rocks that were placed there when the continents were like sutured together. That makes sense. Yeah.
Could you explain an ophiolite sequence? Close enough.
It's just, to my understanding, the ophiolite is it's an igneous rock, and it's like the sort of sequence. It didn't go into the description of like what they were, just that they were like really present in that area, and it's present in a lot of volcanic areas.
Oh, thank you.
Any questions? Yeah.
What were some difficulties in the research that you ran into?
A lot of the research articles I tried to find on this region focused a lot on the Appalachian Mountains, which is not what I was trying to research.